Good morning, students. Last lecture we had stopped and we had given you a homework at this point, so we'll continue from this point. Okay, so we had to calculate the value of g. Okay, so in order to find the value of g, what you have to do is what is that g has come from which formula? G has come from this formula, because gravitational force is also by second law, mass into acceleration. Okay, so small g mg equals to gmm upon d square. So cancelling small m from both the sides, we have g is equals to gm upon r square. Now this value of g, we have to calculate its value by solving this value. Okay, now what is the value of g? G equals to gm upon r square. So what is r? R is the radius, as we can see in the diagram. R is the radius of the earth. Now this object, this height is considered negligible because from here to here it is 6400 kilometers. So 1 meter and 2 meters, if it is added to 6400 kilometers, we can take it approximates to 6400 kilometer only. So we have considered it as this r is equals to d. Okay, now in order to find, therefore the value of g on just the surface of the earth and on the just above the surface of the earth, it is almost equal. But if you take on very much height, then it will be different, because distance will considerably increase. When the distance will considerably increase, then the denominator will increase, and when denominator increase, value of g will also become down. Okay, but we are calculating this formula of g only for small heights or near the surface of the earth only. So we have to calculate the value of g on the near to the earth's surface only. So whenever they ask this value, it is always considered near earth's surface, near earth's surface. Okay, now we have to put the values. Okay, now what are the values? The value of g, capital G, is 6.7 into 10 to the power minus 11. The value of mass of the earth is 6 into 10 to the power 24 kgs. Okay, and the radius of the earth is 6.4 into 10 to the power 6 meters. Okay, if we have to do it squared. Now after solving this, if we don't put the value of g, then we can write the value of small g in terms of capital G. What is that? Small g equals to capital G multiplied by 1.47 into 10 to the power 11. Why we have solved this in rough? Okay, that is, first we have done the square of 6.4, that is 40.96. We have considered it approximately equals to 41. So 6 upon its square is 41. So it is solving 41 zeros are, if you multiply it by 0 here, point, then we have to multiply by 0. So 41 ones are 40, 60, and 190 remaining. 41 fours are, like that we can solve. And we have come to this point because 6 2s are 12, and 24 minus 12 is 12 is 12. So now this is 0 point. Now what we can do is, here multiplied by 10 and here divide by 10. So multiplied by 10 it becomes 1.4, divided by 10 it becomes 1 power less, that is 10 raised to the power 11. This is the value of small g in terms of capital G. But if you put the value of capital G, then you have to multiply 1.4 into 6.7, and multiply minus 11 into plus 11 will get cancelled. So 6 into 1.4, it is coming out to be 9.8. okay, because plus 11 get cancelled with minus 11. Okay, so value of small g is equals to this value as well as this value. We can use this value when we have to compare the value of small g with moon, with Saturn, with Jupiter, and all such planets. So remember both these values. You already know this value, now you remember this value, the value of small g in terms of capital G. Yes students, what is it? Pause and say the sentence. The value of small g is equals to 1.47 into 10 to the power 11 into capital G, that is universal gravitational constant. Okay, this is the value of g on the earth. Write it down, pause the video and write it down. Okay students, that day we had last lecture we had completed some of the problems from this notebook, from this worksheet, as well as some of the problems were there given for homework. If you have completed some problems, then you can check it in the video. Otherwise you can just watch the videos and try to solve it again in rough. Okay, problem 1 was solved, problem 2 was also solved, problem 3 let us see. The cricket ball is dropped from 20 meters. Calculate the speed of the ball when it hits the ground and time taken. Okay, a ball is dropped from 20 meters height. We have two methods. First one is the motion kinematics and second one is gravitational kinematics. In motion kinematics, all the laws are considered as upward positive, downward negative. In gravitational kinematics, what do we have? Approaching the earth, approaching the planet, acceleration is positive. Otherwise, if opposing the gravitational force, it is negative. So we have to solve in this lesson by the method of gravitational kinematics. So we will solve the question 3. A cricket ball is dropped from 20 meters. Calculate the speed of the ball when it hits the ground and also the time taken. So pause the video and try to find the answer. Okay, now let us see how to find the answer. If the ball is dropped from 20 meters height. When it is dropped from 20 meters height, it is approaching the earth with due to gravitational force. We have just found the value of gravitational force upon this body's mass as this body's acceleration due to gravity. That is the value of g. Because the velocity is going in this direction, gravitational acceleration is also helping it. That is why we are going to consider the value of small g, that is force of gravity upon its mass, that is the force of gravity upon its mass. So m and m get cancelled, so gm upon r square, that is nothing but value of g. It is calculated as 9.8 or 10 meters per second square. So this value will be traveling in a straight line with constant acceleration, because near the surface of the earth we considered is as same or constant. Remember it, near the surface of the earth you consider it as constant value of small g. Okay. Now this 9.8, it will travel in straight line with constant acceleration, so you can take the help of kinematics. Now we will see how to solve. Okay, now we have been known that values are written. G is positive, displacement is 20 meters, time is to be found out, g is plus 10 meters per second square, velocity is also to be found out. What we can do? Write down v equals to u plus at. Okay, v is to be found out, but in that we don't know t, so what do? We use another kinematic equation. S is equals to ut plus half at squared, in which s is equals to 20. U is that we don't know. Initially it is dropped, so we can consider it as 0. Time taken is we do not know, so we put it as t. Next, you put the value of a as 10. You put the value of t as again unknown, but we know after solving it, it should come to 20. So the answer of t squared can be found out by equating to 20. This comes out to be 2 seconds. Why? Because 20 meters is equals to s is equals to ut plus half at squared, where acceleration is 10. That is considered as positive because it is along the motion. So we have 2 seconds. 2 seconds if we put here, we get 20 meters per second as the velocity. Okay. Now we will go for the next question. A ball is thrown up with a speed of 15 meters per second. How high will it go before it begins to fall? Okay students, do you understand the question? A ball is thrown up with a speed of 15 meters per second. It will go high, rise higher and higher and higher, and it will stop somewhere, and again it will start to fall. So they are asking how much height it will rise high if its initial velocity is 15 meters per second. So in this question, what you can do is you can consider it by gravitational kinematics also. So students, pause the video and try to find the answer. By gravitational kinematics, this can also be found out by considering as initial velocity as 15 meters per second but this velocity is imparted to the ball, that is ball is having velocity but it is thrown upwards, that is not in the direction of earth's gravitational force. So what we can consider this question as not in the direction of earth, so we can consider it as this question's answer is not solved students, so you have to solve it on your own. Let us see how to solve. Okay, so let us see how to solve this. In this method we will consider first an earth. Okay, and there is a ball which is thrown with velocity 15 meters per second upwards. Upwards means in the direction away from the earth. Now it will travel certain distance, stop here, and then again fall back. Because it is going to stop here, we know that the final velocity is equals to 0 meters per second. When we know final velocity is 0 meters per second, we have the initial velocity as 15 meters per second. Then this distance is supposed to be found out. So s is equals to question mark. Now, any equation in for to calculate this distance? Yes, you know that. What is that? S is equals to ut plus half a t squared, but we do not know the value of time. So we can find the value of time again by this equation. V equals to u plus at. And what is the velocity? Final velocity is 0 meters per second is equals to initial velocity is 15. Let us take 15 as the velocity with the ball. So we have no assumption upwards negative, pump downwards positive, upwards positive, downwards positive. This is not anything like that. Okay, whatever the value is given, it is the associated value. So let us use it directly. That is plus 15 plus what is the acceleration? Now acceleration is not in the direction of the increasing velocity, is opposing the motion. So we have to consider gravity as value of a as minus g, that is minus 10 into time as t. Now this value is plus 15, here it will become minus 15, and this is minus 10 into t. This is 0, plus becomes here minus. So t is equals to minus 15 upon minus 10, that is t equals to 1.5 seconds. Now students, we can use 1.5 seconds time here. So we can get the value as is a ball is thrown up with a speed of 15 meters per second. How high will it go before it begins to fall? Okay, so the ball is thrown upwards, so it will go up and it will again fall down. So it will rise to a certain height, and what is that height it is rising, that we have to find, as well as yes, how high it will go. Now in order to find that, we have to solve it by gravitational kinematics. So in order to solve by gravitational kinematics, first we have to consider earth and a ball system. So there is a earth and a ball system, and it has been given a value u. Now why we have considered positive? Because always we have to consider the motion associated with the ball, motion associated, because we have given it some quantity, right? So that is considered to be positive because we have given it that value. So that is given by us, so that is considered to be positive because we have started it, right? In that motion we have started that motion in gravitational motion, so that is considered positive. Now acceleration, what does it do? It is not helping this motion, so it is trying to oppose it. So that is acceleration is minus g, that is equals to minus 10 meters per second squared. Okay, now it will try to go, and because it has certain velocity, it will try to go in this direction, and it will stop here somewhere. Why? Because this is trying to pull, and again because its value is now increasing, with its velocity here will be what? V will be equals to 0. Now because velocity is 0, now it is already minus 10, that means it will try to pull it in its direction. Okay, so it will try to come in this direction. Now we have asked how much this distance is, right? So we have to find this distance s. Now we will use the gravitational kinematics here in the upward journey only. So what is the upward journey? We have to find the value of s, that is displacement. So what we can do is, what is the formula of s? S is equals to ut plus half a t squared. U is plus 15 into time t plus half, a is minus 10 into t squared, that is will give you the value of s, but we do not know how much time it is taking here. But we know one more kinematics that will help us to find t. What is that? V equals to u plus at. Now what is the value of u? That is plus 15. Okay, plus 15. What is the value of a? That is opposing, so minus 10 into time we do not know, so we have put it, but this value is should give the answer as 0 finally. So we have equated it to 0. Now when it will equate to 0, at what time? So we have to rearrange for this. So 15 here becomes minus 15 plus 10, which is multiplying, here it is dividing. So t should be such that the value which will come 0 is t equals to 1.5 seconds. That means at 1.5 seconds its value is 0. So if you put 1.5 seconds here, it should give you the value such that its distance is becoming, whatever is the distance becoming in 1.5 seconds, you will calculate by this equation. So we have to put 1.5 here. 15 into 1.5, 15 are 225, so it will be 22.5 meters. Okay, this is 15 and this is 1.5. Okay, 15 into 15 we have taken, so 225. 1 point is there here, plus half into 5, half minus 10 divided by half, let me write it minus 5. Okay, t square means what? Again 15 into 15, that is again 2.25. let us write 2.25. I have 2.25 because there are two digits in 1.5 whole squared. Okay, 1.5 into 1.5, it is 15 squares are 225, so we have 1 2, so we have put a point here, In this case 15 into t is 1.5, so 15 15 is 225, and here only 1 point, so we have put a point here. So here the answer is 2.5 minus 5 into 15. What is this value? 22 25 multiplied by 5, 5 5 is a 15, 1 carrier, 5 to the 10 plus 1 11, 1 carrier, 5 to the 10 plus 1 11, so 1 2. So 222.5 minus 11.15, what is the answer? That should be written in meters here, okay, by you. Now this is what the answer is. Now we will go for the next question. Yes, the next question is this one, fifth one. A stone is thrown vertically upwards with initial velocity of 40 meters per second. Okay, initial velocity of 14 meters per second. Now they are asking that yes, taking value of g, find the maximum height reached by the stone when the net displacement and the total distance covered by the, what is the net displacement and total distance covered by the stone. So the object is thrown upwards with initial velocity of 40 meters per second, so it will reach certain height. Whatever is the height it will reach, they are asking what is the maximum height, what is the maximum height covered, and they are also asking find a net displacement and the total distance. Three things they are asking. See, whenever the ball is thrown up, it will reach certain height that we can find out by kinematics. What is the net displacement? It will go up and come down, it will reach the same point, so net displacement will be 0. What will be total distance? Total distance will be upwards plus downwards, that is 2 times of h. So whatever is the value of h we found out, you have to again add with h, so h plus h will be the total distance. So you have to find only the height. Height could be found out by initial velocity 40 meters per second, value of g, it is the upward journey, so we have to take it as opposing, so we can solve it. Okay, so considering it, what is the total height covered? U is plus 40 because we have given it. Okay, motion is imparted by us, so we have given it, started the motion, so we have writing plus 40. Now what is it after starting? Is it helping or opposing? Students, it is opposing, it is trying to go on the other side. So let us start, draw an earth. Okay, the ball is being thrown upwards, it is away from the earth, with we have given velocity, so we will write plus 40 because we have started the motion. Now once we have started, because we have started something, value is started, countable value, so plus value, positive value. But see what happens, it is accelerating, not in our increasing direction of our values, it is opposing us. So a is minus 10. Now these values we know it, that is equals to minus 10. Now we will just put it, the values. See, velocity was what? Final velocity, whenever it is thrown upwards, it will go somewhere here and it will stop here, right? So that velocity stopped, is final velocity is 0. So we have third kinematical equation. Why? Because we know final velocity, we know initial velocity, but we want to find distance. There is no time given. Whenever time is not given, we know that we will solve third kinematics. Remember, when we have initial velocity, final velocity, and we do not have time, in that cases we have to use the third kinematical equation, that is 40 squared plus 2 into minus 10 into s. What should give you 0? That is final 0. So displacement should be such that we can equate it with respect to this initial velocity and 0. So we get the answer 1600 meters per second is equals to, this minus becomes plus here, 40 square is 1600, 20 is multiplying here, dividing it's becoming 80. So 80 meters is the height traveled by the ball.